Hello, Math 1050. This is section 7.3, more on parabolas. There are three topics within this parabola section. So you are familiar with parabolas. This starting topic is about graphing parabolas, but our parabolas could now be one of two things. They could be what you're used to, y equals a times x minus h squared plus k, where you find the vertex just as we normally do, and then think about if it opens upward or downward. But we also now have some parabolas that are in this form, y equals a times y minus k squared plus h. So these type of parabolas are just parabolas that are sideways. So they might open to the right. That would be like a positive stretch, or they might open to the left. So our usual open either up or down. So for this topic, what Alex will have you do is it'll have you plot the vertex, tell which way it opens, if it's to the right, to the left, up or down, and then it will have you plot one additional point using the stretch pattern, and then it will kind of sketch it in there for you. So this first one is x equals 3 times y plus 4 squared minus 5. So when you're finding the vertex, I would write your x and y with it. So looking at this, that tells me that my y value is -4. And so that's in the y position. And then this number over here is my x in this case. So my x value is -5. So our vertex is at -5, -4. Okay, so we would then have to tell if it's opening upward or downward. Well, this one is, or to the right or to the left, sorry. This is definitely sideways. And it has a positive stretch, so it's going to open to the right. So positive opens to the right. And then we'll have to plot one additional point. Well, the stretch factor was 3. So we're going to go to the right 3 and up 1. So it would look like this if we plotted more points. And it's a 1, 3, 5 pattern, but stretched by 3 would be a 3 and then a 9. 3, 4, 5, 6, 7, 8, 9. And so I'm just plotting more points because I don't have Alex to make it for me. So it's a sideways parabola like this. Because, this is a little new, I'm going to do a couple more. Graph of the parabola y equals 2 times x minus 4 squared plus 2. So this is in the y direction. This is more the type that we're used to. So it is going to open upward. The vertex is going to be we've got x equals 4 and y equals 2. So 4, 2. Opens upward, stretch factor 2. So it's going to go 2, 6, 10, up 2, up 6, up 10. Now on this topic, you're not going to have to plot a lot of points, just the vertex and one additional point. I'm just plotting the additional points so that I can complete the sketch for the notes. Okay, so this one is x equals -2 times y minus 4 squared minus 6. So this is a sideways parabola. It has a negative stretch factor, so it is a sideways opening to the left. So if we find that vertex, our y value is 4 and our x value is -6. So our vertex is -6, 4. So right here, Our stretch factor is -2. So it's going to go back to up 1. And down 1, of course. And then it would be 6. So I'm just going to finish sketching. You will only have to plot 2 points in Alex. So that's what our parabola looks like. So just be really mindful of whether it's opening in the x direction or in the y direction. Okay, the next few topics are going to talk about a parabola's vertex, directrix, focus, and axis of symmetry. So one of the definitions of a parabola that is related to the definition of a circle and the definition of an ellipse is that a parabola is the set of all points in a plane that are the same distance from a fixed line as they are from a fixed point not on the line. So the line is called the directrix and the fixed point is called the focus. So if you have a parabola, with a vertex here, the parabola bends towards its focus and away from its directrix. And these are the same parabolas we've always dealt with. This is just sort of another way of thinking about them. And so what that definition is saying, I'm going to show you sort of a visual of it. And you are already familiar with the axis of symmetry. So we will be using that axis of symmetry as well. Okay, so here's kind of a visualization of it, maybe, if it'll pull up. Here we go. So again, I've got my vertex. Right now that vertex is set at the origin. And you can see this orange line is the directrix, and the focus is this point F right here. And the axis of symmetry is notated at the top. So every single point on a parabola is the same distance away from its focus as it is from the directrix, that orange line. So if point A is up here, it's 8.73 units away from the focus, and it's 8.7 units away from the directrix. So it's kind of an interesting definition. If I moved the parabola around, so the directrix would, of course, move with it. And then I can change the distance that the focus is away from the parabola. If I change it too much, I won't be able to move point A, though. Let's see. So here's a parabola opening upside down. You can see point A is the same distance away from that directrix as it is from the focus. Okay, so that's just one way of thinking of parabolas. If this is the way that you're thinking of parabolas, the equation is written a little bit differently, kind of unique and strange. It's written as x minus h squared equals 4p times y minus k. And p is this distance between the focus and the vertex. And then also that distance here, those are both p's. Okay, so this equation is written on your formula sheet for Math 1050, so you will have access to that. And these two forms of the equation are actually equivalent if we define A to be 1 over 4p. And so I just want to show you that really quick. If I start with y equals 1 over 4p times x minus h squared plus k. So all I did was sub 1 over 4p in for A. If I want to solve this equation and get that x plus h squared or x minus h squared by itself, I would subtract the k. So now I have y minus k equals 1 over 4p times x minus h squared. And then I would multiply both sides of the equation by 4p. And so that is the equation that we'll be working with the most, is this one. It's different sides than this, but it's the same. 4p times y minus k equals x minus h squared. So just a new form of a parabola equation. Okay. And that works if it's opening horizontally as well. This equation is also on your formula sheet with the horizontal axis of symmetry. Okay, so what the topic has you calculate is it has you calculate the vertex, focus, directrix, and axis of symmetry for all of these parabolas. Now, it doesn't ask you to graph it. It does not ask you to make a rough sketch, but I think that the way that students are most successful with this topic is if they make a rough sketch. So I have my little spot for my sketch. And so this is the order that I would think about it in. Definitely start with your vertex. Vertex is not too difficult. The x value, it's an x plus 1. So the x value of the vertex is -1. And we have a y minus 5 over here. So the y value is 5. So we get that vertex, and then also think about the direction. So this is the type that this is an x squared is equal to y type. So that's just a regular parabola. It's going to open upward. So here's my rough sketch. There's my parabola, and I just figured out that the vertex is at -1, 5. Okay, so I would not do the focus next. The next thing that I would find is the axis of symmetry. The axis of symmetry just divides that parabola in half. Because this is a vertical axis of symmetry, our axis of symmetry equation is x is equal to -1. Okay, once you have found the vertex and the axis of symmetry, you're going to do a quick calculation of p. So I wrote the form of the equation right underneath the equation that Alex gave me. And the reason I like to do that is because it helps you see what your p is. So I'm going to set up a little equation. In my equation, I see the number 3, and in the form of the equation, just the general form, it's a 4p. So I'm setting these two things equal to each other in order to calculate p. So if 3 is equal to 4p, then our p value is 3/4. So for a parabola, when we're thinking about it in this form, our focus is above or inside the parabola, and our directrix is going to be below the parabola or outside. So finding the focus first, remember P is telling me how far away from the vertex the focus is. So it's 3/4 above. So that point is going to be the same x value. It's right on the axis of symmetry. So it's going to be a -1 x value. But the y value is that it's 3/4 above the vertex. And so 5 plus 3/4 gives me a y value of 23/4. And if I were you, I would keep that in a fraction form, and you can use your calculator to add 5 plus 3/4. So that would be our focus. And again, that is because it is 3/4 above the vertex. And then the directrix is 3/4 below. So we would take that 5 and we would subtract the 3/4. Now the directrix is a line, and in this example, it's a horizontal line. So it's going to have an equation that is y equals a number. And please note the axis of symmetry and the directrix are always perpendicular. If one is horizontal, the other is vertical, and vice versa. So if you have your axis of symmetry x equals a number, your directrix is y equals a number. So 5 minus 3/4 gives us 17/4, and so that's our directrix. And it is below the vertex. And so that's it. We've completed our list. So again, first find the vertex, then find the axis of symmetry. Third, calculate your p-value, and then you can find your focus and directrix once you know that p-value. Okay, here's another example just for a second chance to practice. So same list of things we're trying to figure out. Here's our equation. We're going to start by finding the vertex. So from my equation, I can see that the y is equal to -1 and the x is equal to -3. And then you should also think about the direction. And in this case, we have y squared is equal to -x. That's the same as x is equal to -y squared. So we have a parabola that is opening sideways to the left. So for my sketch, my vertex is at the point -3, -1. Okay, we're done with the first part, the vertex. Now we find the axis of symmetry. The axis of symmetry for this thing, the line that sort of cuts that in half, is a horizontal line, and it's a y equals -1. Okay, once we have our vertex and our axis of symmetry, we need to calculate our p-value. So, thinking about the general form is y minus k squared equals 4p times x minus h. So for our equation, 4p is equal to -7. That means p is equal to -7/4. So our focus is to the left, 7/4 to the left of the vertex, and our directrix is 7/4 to the right. So to calculate the focus, it's right on the axis of symmetry. It has a y value of -1. We need to figure out its x value. And so we need to subtract 7/4 from -3. Be careful with your signs here. -3 minus 7/4 is -19/4. The directrix is 7/4 to the right. So, and it's going to be an x equals, because that's a vertical line, 7/4 to the right of -3 is -5/4. And that is our list of characteristics. Okay, the last topic in this section is some word problems. Now, the nice thing about the word problems in this section is they do provide you with some very, very nice diagrams. And the other thing that's very nice about how these is set up is that we will always have the vertex at the origin. And because in our diagrams, the vertex is the origin, if we substitute in 0 for h and k, our equation simplifies to x squared is equal to 4p times y. So this is the equation we'll be using for these word problems. And again, the reason that it simplifies to this is because we're taking the vertex to be the origin, 0, 0. Okay, so the first one is that we have a lamp that is in the shape of a parabola, which lamps often are because that focuses the light really nicely. The light source is at the focus of the parabola, and it's 2 centimeters from the bottom of the lamp. The lamp itself is 32 centimeters deep. We want to know how wide it is. So we have this nice diagram set up. So the first thing that you want to do is set up your equation. So remember that the distance between the vertex and the focus is p. So our p value is 2. So our equation is that x squared is equal to 4 times 2 times y, or in other words, 8y. So now that we have our equation set up, we're going to use the point right here, a 32, to solve for a. So I'm going to sub in a for x, and I'm going to sub in 32 for y. That gives me the equation a squared is equal to 256. And so if we square root both sides, we get that a is equal to 16. So that means this point over here on the edge is 1632. That means this one over here is negative 1632 because parabolas are very symmetric things. And so our question is, what is the entire distance for that lamp width? How wide is the lamp? So how wide? It would be, we've got 16 on each side. So that would be that it's 32 centimeters wide. So they aren't all set up like this. There's several different iterations. I'm going to kind of go through one of each type. The next one, it's still a lamp, but this time it says how far is the light source from the bottom of the lamp. So in other words, we're trying to calculate P. So our equation setup is x minus h squared equals 4p times y minus k. And again, that's on your formula sheet. Our vertex is 0, 0. So x squared is equal to 4py. We need to calculate p. So we're going to use this point, 12, 9, a point on the parabola, to calculate p. My spelling is strong today. Okay, so if we sub in 12 for x and we sub in 9 for y, we end up with the equation 144 is equal to 36p. And so if we divide both sides of our equation by 36, we get that p is equal to 4. And that is what we were after. We wanted to know how far away the light source should be from the focus. And so 4 centimeters is our answer. Okay, another type you might see is involving a bridge. So this type actually is a little bit more complicated than the light ones. We are going to start by setting up our equation and solving for P. Because you can see that it doesn't give us any information about the height or the distance of the focus. So we have a suspension bridge with 2 towers. The towers are 160 meters apart, and the height of each tower is 8 meters. So we have this point 88. We're going to start with that one. And we're going to use that to calculate P. Oh, whoops, sorry. I got crazy there. No squared on the y. Okay, so we're going to sub in 80 for x and 8 for y. So we get 80 squared is equal to 4p multiplied by 8. So that's the same as 80 squared is 6,400 is equal to 32p. And so if we divide by 32, we get 200 is equal to p. So now that we know what p is, if we substitute that p value into our equation, we get the equation x squared equals 800p. And I got the 800 by timesing the p value by 4. Oh my gosh, that's a y. I'm sorry. Okay, so now that we have that equation, we're going to think about this point. We're trying to answer how high is that point. So we're looking for its y value. So we're going to use that point 40b and solve for b. So 40 squared is equal to 800, and our y is now a b. So if we want to solve that, 1600 is equal to 800b. If we divide by 800, we get that b is equal to 2. So it's 2 meters high right there. And then a variation of this one is that it might ask you how high the tower is. So this one tells us that the towers are 128 meters apart. And then the cable is 2 meters high when it's 32 meters from the center of the bridge. So again, our generic equation is x squared is equal to 4py because our vertex is the origin. So we're going to first use that point that we know, 32, 2, and we're going to use that to calculate p. So 32 squared is equal to 4 times p times 2. 32 squared is 1024. And so if we divide by 8, we get 128 for our p value. So if we substitute that in, 4 times 128 is 512. So now our equation is x squared is equal to 512 times a y. So now we're going to use our other point. If the x value is 64, we want to know what the y value is. So 64 squared is equal to 512 times b. 64 squared is 4,096. And so if we divide by 512, we get that our height is 8 centimeters. Okay, so that's it for the parabolas. Let me know if you have any questions. Thanks so much.